Hello, my dear students. Welcome to BYJU'S exam prep. Hope you guys are fine. So, guys, be quick and join the session fast. Be quick. I guess I'm audible and I'm visible. Okay. So, we'll start with the session, but before that, let me quickly tell you about few things. Guys, if you are new to this channel and if you don't know about me, you can go through my profile. Next, coming further, if you don't know, guys, Super Saturday on every Saturday, in which we cover Know the Legends and Raftar series. Similarly, we have Sunday Ka Funda, which deals with civil, mechanical, experiments, or you can say the knowledge which you have studied in your college, what all you things you can see it practically on daily basis. Plus, we have daily dose. So all these three are the initiatives. If you haven't subscribed our channel, kindly do so. Next, coming further is, guys, there's a workshop on 25th of July that is coming Tuesday at 7:30 p.m. So if you are targeting for GATE 2024, what should be your preparation strategy? Okay, now coming up next, there's a scholarship test on this coming Sunday. The best part of it is you can give the test anytime between morning 9 a.m. to 9 p.m. in the evening. Okay, so this time there's no time constraint. Whenever you feel like fine, I'm free, I can give the test, then definitely you can go for giving the test. Okay. Fine. Now we'll start further with the questions part and all. So guys, be quick. Come on, guys, be quick. And before that, let me tell you, you can join my Telegram group for further upcoming classes, and all will be told to you here. Okay, and GATE preparation ebook link is in the description. You guys can click on it. And one more thing, which I'll tell you at the last also, and I'm telling you right now also. Tomorrow at 10 a.m. we'll be having the mock test for GATE for civil engineering students. So guys, do attend this mock test. Doesn't matter if you have studied 2 subjects or 3 subjects, but give the test so that you can see the variety of questions which can be asked and how to attempt those questions. Okay, so now be quick, guys. Share the session fast so that we can start it early. Come on. Be quick. Okay, so now let's start with the session. In today's session, I won't be only covering infiltration concepts, but we'll be also dealing with the numerical part. Okay, so let's start the session. First, in this session, first we'll be talking about infiltration and infiltration capacity. All these things we'll be talking about. Okay, so one by one we'll move. And guys, you know that this year infiltration 2 marks questions in the forenoon session has been asked, and 2 marks question for infiltration, and for other Theson's polygon questions were also there. So you cannot leave this topic, because every year, not only for GATE, if you're preparing for other examinations also, infiltration is a topic which is asked on frequent basis. Okay, so now we'll start. What do you mean by infiltration? What is infiltration capacity? We'll talk about each and everything. Okay, now when you talk about infiltration, what do you mean by it? In Hindi you say कि जो पानी गिरता है और वो नीचे soil absorb कर लेती है. ठीक है, because when the rainfall happens or when the precipitation occurs, it's not that every part of precipitation contributes to runoff. No, there are n number of losses. You have interception loss, you have transpiration loss, there is a base flow taking place, prompt interflow taking place, n number of things, evaporation, n number of things are taking place. Okay, now out of that abstractions from precipitation, there is one more thing, that is infiltration. Now, infiltration is important because a significant part of precipitation contributes to infiltration. It is not like 1-2%, 1-2% that if you give 1-2%, that's enough and that will contribute to infiltration. A significant amount of precipitation contributes to infiltration. Now, what do you mean by infiltration? Infiltration is the movement of water into the soil. Okay, so the movement of water, in some books you will find they mention it as vertical movement of water into the soil, is termed as infiltration. Okay, so the process by which the water gets absorbed into the soil, you call it as infiltration. Got it? So is there a difference between infiltration and infiltration capacity? Yes. Infiltration is the movement of water into the soil. But when you talk about infiltration capacity, that is the maximum rate at which a given soil at a given time can absorb water. Okay, so you're talking about a particular soil. Okay, at a particular time, the maximum, see, rate, whenever we talk about rate, always remember, rate is with respect to time. Okay, rate is with respect to time. So the maximum, there can be not more than the infiltration capacity. That is the saturation point. Okay, above that, there will be nothing more than infiltration capacity. There can't be any infiltration. Okay, so the maximum rate at which a given soil at a given time can absorb water is termed as infiltration capacity. Okay, generally we denote it by FP and we express it in centimeter per hour. It's not that you cannot express it in meter per hour or mm per hour. Generally we express it in centimeter per hour. Okay, now let's talk further. That I told you about infiltration process. I told you about infiltration capacity. Now let's talk about the one question which can be asked for 1 marks. Okay, but definitely it has been asked in many of the examinations, and definitely it can be asked in 1 marks for gate as well. Now you know that I is the intensity of rainfall. Consider the units. Let us suppose centimeter per hour is for intensity of rainfall also, and actual rate of infiltration is also in centimeter per hour. Okay, we take the units as same for everybody. Now what happens if I is the intensity of rainfall and F is the actual rate of infiltration? Now what happens? It might happen that intensity of rainfall could be more than infiltration capacity. Okay, ज़्यादा बारिश गिरी, maximum rate of infiltration से ज़्यादा बारिश गिरी, or it can be there that intensity of rainfall is less than the infiltration capacity. Both can be there. So guys, if intensity of rainfall is more than the infiltration capacity, in that case, actual rate of infiltration will be equal to infiltration capacity. Similarly, if intensity of rainfall is less, that means whatsoever rainfall is taking place, each and every rainfall is getting what? It is getting absorbed into the soil surface. So in this case, actual rate of infiltration will be equal to intensity of rainfall. Got it? Any doubt till here? Okay, so if they give you in terms of statements or they give you in terms of denotions, you should be able to solve it. Okay, now coming further, this is infiltration capacity. Now, how do we calculate the infiltration at a particular time? One thing. And how we'll calculate the cumulative infiltration. That means I don't want to know at first hour how much infiltration came, or at second hour how much infiltration came. I want to know the total infiltration of 10 hours. I want to know the total infiltration of 5 hours. So how can I calculate that? So that is given by Horton's equation. Okay, Horton sir has given the equation for it. How you calculate this Horton's equation? Let's talk about it. FP is the infiltration capacity which you need to find out. Got it? This is a very basic equation asked in GATE n number of times. Okay, you can't count it in fingers because it has been asked so many times. Now, FP is the infiltration capacity at any time t. Now, you know that initially infiltration capacity. Now, I'll draw it. This is time curve. This is infiltration. Okay, the curve follows something like this. Got it? Now what happens at t is equal to 0, when time was 0, infiltration capacity was how much? F naught. Now what happens as the time passes, the infiltration will decrease. Why? Because maximum amount of water has already been absorbed into the soil surface. Okay, so it will decrease and ultimately after a time it will become constant. Okay, so initial infiltration capacity will be definitely more, F naught, plus F naught minus FC. FC is the final infiltration capacity. That is the one which will become constant. Okay, that will the one which will become constant. What is KH? Kh is the Horton's decay coefficient. Now remember that what does it depends upon, because sometimes they'll give you MSQ pattern of questions and they can give you the statement that Horton's decay coefficient depends upon soil characteristics and vegetational cover. Okay, so whether it's true or not, so that's the reason. Don't remember K is a constant. Remember what does it depend upon. So Horton's decay coefficient depends upon soil characteristics. It depends upon vegetative cover. T depends upon the duration in which you are calculating this infiltration capacity. The total duration in which you are calculating this infiltration capacity. Now if you want to calculate the cumulative, nothing to do. Just what you have to do. Integrate it. That's it. This will be the cumulative infiltration capacity. Got it? Now, coming up further, guys, if you have any doubts, do let me know that also. Okay. Now, talking about next, this is the cumulative infiltration capacity. Now, let's calculate through questions. Make sure one thing, that Horton's equation only you can apply when intensity of rainfall is greater than or equal to infiltration capacity. If this condition doesn't persist, you won't be able to apply Horton's equation. That is very, very necessary. Okay. Now, let's go for the first question. Come on, guys. Try to solve it. Come on, be quick. Quick, quick, quick. Fast, fast. I want everybody to answer. These are like, you have to apply your brain, but these are not that difficult. Come on, be quick. Okay then. Let's start with the question. A 6-hour storm occurred over a catchment of 1.8 kilometer square area, and the total rainfall observed was 24 centimeter. So the total precipitation was how much? 24 centimeter. An infiltration capacity curve is given to you. Basically, they have given the dimensions. Initial infiltration is how much? 2 centimeter per hour. I'm taking this denotation. Okay, I'm taking this denotations. You want, you can take some books, you find it, they write it as FI for initial and FF for final. So you can go for that also. Okay, that depends upon you. You can go for that also. So initial and final. Okay, I'll take F naught for initial and FC for final. If you want, you can take FI for initial and FF for final. That depends upon you. Okay, so initial infiltration capacity is 2 centimeter per hour, attained a constant value of 0.5 centimeter per hour. That means FC is given to you how much? 0.5 centimeter per hour. Okay, Horton's equation constant is given to you as how much? 5 per hour. Now what happens? An IMDB, Indian Meteorological Department, has installed a pan, and it indicated a decrease of 0.8 centimeter in the level of water. How much time? In 6 hours duration of time. So you have to tell the runoff. So you know that runoff is equal to how much precipitation occurred, how much losses took place. Here in this question you have two losses. What are those two losses? One is the infiltration loss and second is the evaporation loss. Ma'am, how come you know evaporation loss? Because in this question pan coefficient is also mentioned. Got it? So now let's calculate the infiltration loss first. Hello Sai Krishna. So first we'll calculate the infiltration loss. Initial is given to you and final is given to you what? 0.5. So this will be how much? 2 minus 0.5 e to the power. Okay. So this will be 0.5 plus 1.5 e to the power minus 5t. This is the infiltration, okay, capacity. So this will be FP. Now you want to calculate cumulative. So what you will do, you will integrate. For how much time it is asking? After 3 hours. So 0 to 3. Point 0.5 T. I'm just integrating. I guess you know the integration, guys. So there's no issue with the integration part, I guess. 0 to 3. Okay, now when you integrate 0.5, upper limit minus lower limit plus, come on, solve this and tell me how much it is coming quickly. Everybody, guys. 0.5 into 3. It is asking for after how many hours installed in the water level during 6 hours. So technically in the question it is asking me an IMD has installed and decrease in water level during 6 hours of catchment. So basically during 6 hours it is asking us. So technically we have to calculate after 6 hours. Remember, confusion it is given. It has told that initially the infiltration capacity was 2 centimeter per hour. 3 घंटे बाद आफ्टर 3 आवर्स इट वाज 0.5 सेंटीमीटर पर आवर. ठीक है, बट जो टोटल कैलकुलेशंस we'll do with respect to 6 hours. सी 3 आवर्स के बाद कांस्टेंट है तो 6 आवर्स के बाद भी वो कांस्टेंट ही रहेगा बिकॉज इट हैज अचीव्ड अ फाइनल इन्फिल्ट्रेशन रेट. Okay, so we have to do our calculations with respect to 6 hours and not with respect to 3 hours. This is one of the things, the tricky thing for you guys to get confused. Okay, so that's why 0 and 6 minus 0 and this will be also 6. Now solve it, guys. 0.5 into 6 will be 3 and when I calculate this one, 1.5 divided by 5, this will be 0.3 e to the power fine. It is coming 0.3 only, so 0.3. So this will be how much? 3.3. Got it? It will come 3.3 centimeter. This is the infiltration. But what you have? You have what? You have a evaporation loss also. So how much evaporation loss you are having, guys? Pan coefficient is 0.7. What else? How much is the decrease in water level? 0.8. So 0.7 into 0.8. This will make how much? 8 sevens are 56. 0.56. So this much is again a decrease. Now the total rainfall which took place was how much? The total rainfall which took place was how much? Total rainfall, guys. Is it given? Yeah. Total rainfall observed was 24 centimeter. So the total rainfall was 24 centimeter. Out of this, 0.56 is the infiltration loss. Out of this, 3.3 centimeter is the infiltration loss. So how much it will come? 20.14 centimeter. So this will be your answer, guys. This will be your answer. Got it? So simple question only it is there, but the thing is you have to get only one thing in which you can get confused is 3 hours and 6 hours. That's the only thing. And one thing which is given like a hint for you, just check it out. A 6-hour storm occurred over the catchment. कैलकुलेशन इतनी होगी तो नहीं हो पाएगा हमसे. क्यों नहीं हो पाएगा यार स्वप्निल? अभी इस साल ही जो क्वेश्चन आया था उसमें इतने कैलकुलेशंस थे एंड 2016 से अगर आप देखो बिकॉज 2016 वाज द फर्स्ट ईयर इन विच दिस वर्चुअल कैलकुलेटर वाज बीइंग इंट्रोड्यूस्ड. हर साल हॉटन्स इक्वेशंस पूछा जाता है बेटा. तो ये जो आप बोल रहे हो ना कैलकुलेशन कम्स विद प्रैक्टिस. वर्चुअल कैलकुलेटर में यू हैव टू प्रैक्टिस देन ओनली इट विल हेल्प यू. गॉट इट? ओके. नाउ दिस इज द वन क्वेश्चन. चलो अब नेक्स्ट क्वेश्चन कर लो. ये थोड़ा सिंपल है एंड दिस क्वेश्चन इज व्हाट? दिस क्वेश्चन इज एमएसक्यू. दिस क्वेश्चन इज एमएसक्यू. ठीक है. हियर already Horton's equation is given to you, so don't have to worry regarding it. Solve it and you have to tell the correct statements. चलो ये तो easy है. चलो now here क्या निकालना है that you will come to know through the options part. Total depth of infiltration in 40 minutes is, average infiltration rate is. So you have to calculate two things, total depth of infiltration and you have to calculate average infiltration rate. Concepts milta julta hai. 40 minutes if you talk about, generally you don't express here in minutes, you express here in hours. So 40 minutes, how can you write? If you will convert it into hours, it will be 2/3 hours. Okay. Now what you have to do, you have to tell the total depth of penetration. जब total पूछ रहा means it is asking you cumulative or you can call it as accumulated. When it asks you accumulated, what you have to do is you have to do the integration. So let's integrate from 0 to 2/3. 13 plus 29 ही है ना. एक मिनट में क्वेश्चन. हाँ 29. सॉल्व कर रहा है कोई कि मैं ही करूँ? 29 e to the power अब so many times we have done it कि मैं directly integrate करके लिख दे रही हूँ. Come on guys, at least calculate it. 2/3 हो गया, इसको calculate तो कर दो थोड़ा. Like this will be 13 into 2/3 plus ये तो minus हो जाएगा. 29 divided by 1.5 19.3333 आ रहा है 34. ये क्या हो गया? e to the power -1 minus e to the power -0. How much it is coming? Not coming answer. ये कैसे आ गया भाई? क्यों नहीं आ रहा? चेक करने दो. 13 into 2 divided by 3. तो ये होगा 8.66 minus 19.34 e to the power -1 minus e to the power जो कि 1 हो जाएगा. ये आ जाएगा 12.225 प्लस 8.666 आ तो 12.225 प्लस 8.666 20.891 तो आ गया यार. 20.891 इसमें होगा mm में. So what was the two options? 20.891 और एक ऑप्शन था 23.66. So A will be the correct. The total depth of infiltration in 40 minutes will be 20.89. सही तो आ तो गया. सही एक बार और calculate, do it the calculation once more. Okay. First one thing. Now what you have to do, you have to calculate the average infiltration rate. Now how will you calculate average infiltration rate guys? This is very very simple. Average infiltration rate. Ma'am, कितने hours के लिए? The question it has asked for how many hours? 40 minutes only. So calculate average infiltration rate for 40 minutes. Total infiltration you got how much? 20.891. So average infiltration rate कितना हो जाएगा? .891 mm. And how many hours? 40 minutes. That is 2/3 hours. How much it is coming? How much it is coming? 31.3365. So 31.33 mm per hour. So देखो. Now we have solved one question regarding MSQ also. So such pattern of questions. I am telling you the various pattern of questions which can be asked. Got it? Now, coming further to the next one, that is question number 3. Now calculate it. Here you have to calculate surface runoff. चलो, यहाँ पर भी थोड़ा सा changes you can find it out. The interception through the soil during rainfall of uniform intensity 5 mm per hour can be calculated using Horton's equation. Initial infiltration capacity is given to you as 6 mm per hour. Final infiltration capacity is given to you as how much? 2 mm per hour. Now it is asking you to calculate runoff during first 2 hours. How will you calculate guys? Be quick. How will you calculate? अब देखो इस क्वेश्चन में बहुत बढ़िया चीज है. Naturally, जब भी whenever you deal with the questions, such pattern of questions, I'm telling you a very important thing. In that questions, generally they give you the expression. अब इस क्वेश्चन में इफ यू आर नॉट पेइंग अटेंशन टू द कंसेप्ट व्हाट यू विल डू, 2 आवर्स के बाद पूछा है, सिंपल 2 बेसिकली। इसकी नेप कहाँ चली गई यार, जस्ट अ मिनट, पेन नेप इज गॉन समवेयर, होल्ड ऑन फॉर अ मिनट गाइस। Okay, I have to change the pen also. Okay guys, got it. Got it. So now what you know is, simply what you do is fc plus f naught minus fc e to the power minus kst. So what you will do is 2, 6 minus 2 e to the power minus kst, that is 2 plus 4 e to the power minus kst, which will become very, very wrong. Why? Because guys, if you read the question properly, it has told you rainfall of intensity is how much? 5 mm per hour. ठीक है, initial infiltration capacity is given to you as 6 mm per hour. How will you do it? How will you do it guys? Come on, quick. Anybody? Guys, 4 e to the power minus kht ये था, इसको इक्वल करेंगे 5 mm per hour के, because you don't know, there should be a time when initially आपका rainfall कम था, ठीक है, rainfall was 5 mm per hour but infiltration was 6 mm per hour. So directly Horton's equation you cannot apply. हर बार जब भी वो denotions expressions दे देते थे, you were able to do it, but right now you won't be able to do it. Why? Because if you read the statement properly, initially infiltration capacity is more. How much? 6 mm per hour. And how much is the rainfall intensity? 5 mm per hour. So first you need to know at what time इंटेंसिटी ऑफ रेनफॉल, बारिश ज्यादा हो, इनफिल्ट्रेशन कम हो. ध्यान रखना, हॉटन्स इक्वेशन तभी लगा पाओगे जब ज्यादा बारिश हो और इनफिल्ट्रेशन कम हो. अगर बारिश कम हुई और इनफिल्ट्रेशन ज्यादा हुआ, यू वोंट बी एबल टू अप्लाई दिस हॉटन्स इक्वेशन. और ये चीज अभी हो रही है, तो आपको पता करना है कि एक टाइम ऐसा आएगा, वो टाइम आपको पता करना है जब बारिश ज्यादा होगी और इनफिल्ट्रेशन कम होगा, और वहीं से आप हॉटन्स इक्वेशन लगा सकते हो. क्योंकि मैंने आपको पहले ही बोला था, मोस्ट इंपॉर्टेंट थिंग ऑफ हॉटन्स इक्वेशन इज इंटेंसिटी ऑफ रेनफॉल हैज टू बी ग्रेटर देन इक्वल टू इनफिल्ट्रेशन कैपेसिटी. गॉट इट? तो पहले आपको वो चेक करना पड़ेगा. सो दिस विल बी 5 minus 2 will be 3, 3 by 4, 0.75. 0.75. K is how much? 2.60. 0.75. Now you will take log on both the sides. Log E base E will become 1, log E 0.75. Okay. When you will solve this, you will get the value of time. How much will be the timing coming? Calculated, it will come out to be 0.11 hour. Just check the calculation once. Huh? So that means after 0.11 hour, whatsoever will be the rainfall, it will be more than the infiltration capacity, and that time only you will be able to apply Horton's equation. So let's calculate it guys. So you will be able to apply it from 0 to 0.11. This will be 2 plus 4. K is how much? 2.6. And before that whatsoever was the rainfall, that was converting it into infiltration. Got it? So this was again infiltration was 5 mm per hour was the rainfall. So for 0.11 hour, whatsoever was the infiltration, whatsoever was the rainfall was getting converted into infiltration. Chalo. So this will be 0.55 plus 2. अब मैं डायरेक्टली इंटीग्रेट कर दिया भाई, इतनी बार कर चुका है ना. 4 minus 2.6, and you have to practice in such a manner कि आपको भी एक ही बार में करो, वहां पे ज्यादा टाइम नहीं है, कन्वेंशनल पेपर नहीं है गेट आपके लिए. Okay, solve it. How much you will get? Solve this guys, solve this properly. you will get 4.927. So 0.55. Just check the calculation once. Cross check हो जाएगा तो अच्छा है. 5.477. This is the infiltration. Now it is asking for how many hours? 2 hours. So the runoff which was taking place, the runoff precipitation, बारिश कितनी हुई total? 10 mm की बारिश हुई. ठीक है, 10 mm की बारिश हुई. Out of that, how much was the infiltration? 5.47 mm was the infiltration. So 5 into 2, 10. 10 minus 5.477. This will come out to be how much? 4.523 mm. This will be the answer. Got it? So this question, guys, it's important because generally जब आपको expression format में दिया रहता है, it becomes easy. But when it is given in this format, तुरंत strike करना mind में, that becomes very very difficult. Got it? Come on. Now this question, this year forenoon session 2 marks GATE 2023 has been asked. Maximum students, even I was not sure, I'll tell you, the paper when it came, in that some people wrote, some people were saying me in the comment section, I was asking that ma'am, W index was mentioned. Some students were telling me no ma'am, phi index was mentioned. Maximum students did it incorrect. They calculated W index and they substituted it. If it would have been an MCQ, then you could have got an idea, but otherwise maximum students have substituted W index. Let's calculate it. How to calculate? Once you should explain about phi index and W index. Okay, you want me to explain phi index and W index? First, I'll explain that only. You want me to explain, Pawan? Fine. Let me add a slide for you to explain. Just a minute. I'll add a slide. Fine. Cool. Fine. Okay. Fine. Well, I have already taken a session on this infiltration indices, but I'll tell you quickly what is this infiltration indices. Okay, now what happens? Horton's equation told you that after 2 hours this much is the infiltration. At particular time what is the infiltration? But when you're designing, let us suppose tomorrow you are thinking of designing dams or any hydraulic structures. You're interested that you don't want to know that at any time t what was the infiltration. You will tell me on an average how much was the infiltration. You are not bothered that after 1 hour what will be the infiltration or the cumulative infiltration after 10 hours. No. They'll ask you that tell me what is the on an average how much infiltration takes place in this particular soil. That's the thing. Because Horton's was telling you cumulative. But you want to know that. So that's why we talked about infiltration indices. Okay. We talked about infiltration indices. Now, in this we have two infiltration indices. One is your W index. One is your phi index. Now let's talk about it. Now, both are denoting you the infiltration only. Now, ma'am, what if both are denoting as infiltration only? Then what is the difference between W index and phi index? Tell us that also. So, see, when you are calculating the average infiltration over the entire storm period, that is known as W index. You are just calculating how much precipitation happened, P. How much of that water drained off, R. That means how much water came minus how much water drained out. The remaining will be infiltrated into the soil. So P minus R divided by D. That's simple. This is your W index. Now, what happened was, this one thing which has not been asked in GATE till now, but I always make sure that I practice such questions so that it is in your head. Now, what is that? We have two types of initial losses. Interception loss and depression storage. I have dealt a Sunday ka Funda video also, interception. You can go and see it. Now, what I mean to say by interception? Guys, actually interception is also divided into two categories: natural interception and artificial interception. Now what happens is, guys, when you talk about natural interception, the water which is stuck in the leaves and all at the time of precipitation, that is natural interception. Artificial is in the rooftops of your houses. There are certain water which gets accumulated during the rainy season, which you guys can check it now also. Okay. Now, similarly, depression storage in ditches and all, wherever the water gets accumulated, or in the rivers or ponds or lakes, that is depression storage. Now, practically, it is very, very difficult to tell exactly how much interception and depression storage came. It's not practically possible. You can use some empirical formulas, but it's not a guarantee that it will give you the actual results. Moreover, it becomes very, very difficult to calculate interception and depression storage. To be precise, for natural interception, although some scientists, researchers have given the equations, but artificial interception किसी ने दिया ही नहीं है. कैसे निकालोगे? अब कैसे पता करोगे हर किसी के छत में कितना पानी accumulate हुआ? How could you know that from each and individual's houses how much water is being accumulated? It's not possible and it's not practically. How can you calculate it? तो यार बात तो सही है. तो पर W index बोला नहीं. मैं इसको infiltration में include नहीं करूंगा. I will not include this initial losses in my infiltration. So these losses are being subtracted from W index. Again, this is a statement wise question. Initial losses are excluded in W index. ठीक, but इसको calculate करना तो difficult है. So phi index told that कोई बात नहीं, interception depression storage की value is small only. So if phi index told कि whatsoever value you get it for interception and depression storage, I'll consider that as infiltration only. Okay, I'll consider that as infiltration only. So infiltration में initial loss consider होता है in the case of phi index, while initial losses is not considered in W index. Got it? So phi index will be precipitation minus runoff divided by time. Why? Because initial losses are also considered as phi index, and that is one of the reason phi index at max can be equal to W index, otherwise it will be greater than W index. ठीक है. अब phi index का एक चीज और है. Phi index will take only that precipitation which produces runoff. तो मैम अगर कोई बारिश हुई जिससे runoff produce नहीं हुआ, तो क्या उसे phi index नहीं लेगा? No. Phi index will not take that precipitation which does not produces runoff. Okay. So precipitation during rainfall axis. Rainfall axis बोल दो, effective rainfall बोल दो. So it is that rainfall which produces runoff. And T is got it? So I guess now you understood the difference. Clear, Pawan? What is W index? What is phi index? Now let's calculate it. This question. Let's calculate it. A 12-hour storm occurs over a catchment. So this is the whole diagram is given to you. How much rainfall intensity, how much time. So it has given you the runoff depth. Runoff diya question mein. Time duration is given to you in this figure and it is asking you to calculate phi index. Okay. Now for calculating phi index, पहले तो आपको runoff पता होना चाहिए, which is given. But you need to know कि कितना precipitation which produced runoff, what was the time, everything you need to know. Okay, कोई बात नहीं, sorry नहीं, अच्छा, it's good you have asked me. Okay, now whenever in the question they are asking you phi index, it is very, very important to calculate W index. If W index is not given you in the question and it is asking you to calculate phi index, सबसे पहले you have to calculate W index. This is the protocol, this is the method you have to follow. Okay, so first you will calculate W index. Precipitation minus runoff divided by duration. Runoff is given 100 mm, but precipitation आपको निकालना पड़ेगा. Now check it out. Rainfall intensity mm per hour into hour कर दूंगी तो मुझे precipitation मिल जाएगा. That means I have to calculate the area. ना अब आप चाहो तो एरिया ऑफ 2 ट्राइंगल्स प्लस एरिया ऑफ रेक्टेंगल कर सकते हो. व्हाट आई डू इज आई डायरेक्टली कैलकुलेट एरिया ऑफ ट्रेपेजियम. हाउ मच इट विल बी? हाफ सम ऑफ पैरेलल साइड्स. वन पैरेलल साइड्स इज 12, another parallel sides is 6. यहाँ से यहाँ तक 6, यहाँ से यहाँ तक 4. 6 minus 4, that is 2. And what is the distance between them is 20. So this will come out to be how much? 2 1s are 2, 2 10, 140. Correct? So 140 mm minus 100 mm. And how much is the time duration? 12 hours. So let's calculate it. 40 divided by 12, that will be come out to be 3.33. This is the W index. 3.33. कुछ यहाँ बना देती हूँ. Diagram is not on scale. 3.33. Now, this is very much clear. Whatsoever will be phi index, it will be more than W index, or at most it can be equal to W index. Now, phi index बोलता है I will take only those precipitation which produces runoff. वही बारिश को लिया जाएगा जो runoff produce करे. अब 140 mm की बारिश में सबने क्या runoff produce किया? नहीं. इतना पोर्शन हो गया infiltration और इतना हो गया runoff. मतलब ये वाली बारिश ने runoff produce नहीं किया, यहाँ वाली कुछ बारिश ने runoff produce नहीं किया. For how much time? पता करो कितने टाइम के लिए ऐसा हुआ और कितनी बारिश ने हुआ. So let's calculate that. यहाँ पे मैंने एक परपेंडिकुलर ड्रॉप किया. ठीक है, चलो अब कैलकुलेट किया जाए. मुझे क्या क्या कैलकुलेट करना है? मुझे यहाँ पे सिमिलर ट्राइंगल्स लगा के कैलकुलेट करना है फॉर हाउ मच टाइम दिस हैपेंड. ठीक है, सो सिमिलर ट्राइंगल्स होगा 20 डिवाइडेड बाय 4 इज इक्वल टू 3.33 डिवाइडेड बाय T1, क्योंकि ये वैल्यू तो 3.33 आई है. ठीक है, सो यहाँ से 20 divided by 5 divided by 3.33 आ जाएगा. हाउ मच? 1 point कितना? 3.33 आ रहा है ना. 3.33 0.6666 आ रहा है. सो लेट मी टेक इट एज 0.67 hours. सो यहाँ पे जो T1 है दैट विल कम आउट टू बी 0.67 hours. ठीक है, फ्रॉम हियर आल्सो आई हैव टू कैलकुलेट, क्योंकि ये वाले टाइम में भी पूरा का पूरा रन ऑफ प्रोड्यूस ही नहीं हो रहा है, सबका सब इन्फिल्ट्रेट हो जा रहा है, एंड दैट विल नॉट बी टेकन इनटू phi index. So let's calculate that also. 20 divided by 12, 3.33 divided by T2. एक मिनट, ये वाला ट्राइंगल यहाँ से यहाँ तक 12 है और यहाँ से यहाँ तक 6 है, तो 12 minus 6 6. ये ट्राइंगल ले रही हूँ ना, रुको दूसरा कलर से दिखा भी देती हूँ इनकेस डाउट होगा तो. ये एक ट्राइंगल था, okay, and this was one triangle. Okay, similarly this is one triangle and this is one triangle, छोटा वाला. Okay, so let's calculate T2. 20 divided by 6 कितना आ रहा है? ये हमारा 0.9999 आ रहा है, so that is 0.99 hours. 0.99 hours. अब कैलकुलेट करना, तो देखो ये मेरे सर पे तो नहीं टकरा. चलो 140 mm की टोटल बारिश हुई, पर उसमें से ये वाला ट्राइंगल और ये वाला ट्राइंगल ने रन ऑफ प्रोड्यूस नहीं किया. इट डजंट प्रोड्यूस रन ऑफ. यू कैन सी इट, ये ऊपर वाला रन ऑफ प्रोड्यूस कर रहा है इतना वाला, और ये वाले ने रन ऑफ प्रोड्यूस नहीं किया. So total precipitation you will subtract this 2 because phi index include that precipitation which produces runoff. So area triangle half 0.67 into 3.33 minus half ठीक है, ये पूरे के पूरे आएंगे इनटू ये वाला 0.9 माइनस रन ऑफ. ये पी आया है. रन ऑफ कितना है क्वेश्चन में दिया? 100 mm. और ड्यूरेशन टोटल थी 12 आवर्स, बट इसमें से 0.67 आवर्स फ्रॉम द स्टार्टिंग एंड 0.99 आवर्स ने रन ऑफ प्रोड्यूस नहीं किया, तो उनको सब्सट्रैक्ट कर दिया गया. हाउ मच इट विल कम गाइस? 3.6 आएगा. जस्ट चेक इट आउट इफ कैलकुलेशन इज योर्स. हाँ ठीक है, आई विल कैलकुलेट, आई विल टेल यू इन द नेक्स्ट सेशन, आई विल टेल यू दैट. Okay, so 3.6 mm per hour will be the answer. Got it? So such pattern of questions can be asked for sure. और ये तो इस साल पूछा गया है, तो अगर कल को बोलोगे कि मैम इतनी कैलकुलेशंस आएगी क्या, हम लोग कैसे कैलकुलेट करेंगे वर्चुअल कैलकुलेटर्स में, सो गाइस डोंट थिंक इट कि नहीं कर सकते हो, इसी साल पूछ लिया गया है. तो सिमिलर ट्राइंगल्स लगाना, कैलकुलेट करना, एरिया निकालना, एंड एवरीथिंग हैज बीन आस्क्ड इन गेट. Okay, so you can't say that it can't be asked in the further times. Definitely it can be asked. Got it? So this was the numerical for you guys. This was the numerical for you guys. Now one numerical I'll give you as homework, so try to do it. This is a numerical homework for you. Kindly do it and comment in the comment section so that I can know. I have told you all the 4 questions were different from the other. There was no 2 questions whose concepts were very common. Okay, they were different. So try to practice such more questions of infiltration. One question I have given you as homework. Now see here, इन लोग ने infiltration का ज़्यादा आपको expression दे दिया. But in the question number 2 or 3, I guess, not given. So there you have to apply that when intensity of rainfall will be more than infiltration. Got it? So that's all guys, and let me tell you, tomorrow at 10 a.m. we are having white नहीं दिख रहा. At the end, just a minute. Okay, so tomorrow at 10 a.m. we are having a mock test. So जितना भी पढ़ा, how much you have studied, two subjects, 2 chapters, 3 chapters, whatsoever it is, you have to do what? You have to come and give it. Okay, you have to give the mock test. Okay, so that is what you have to do, and make sure that you come tomorrow at 10 a.m. sharp. Okay, and don't miss it. And that's it. My laptop has stuck, I guess. Okay. No, it's okay. So that's it. Scholarship test link is in the description, which you guys can click on it. And if you haven't subscribed to our channel, do so. Thank you, everybody. Take care of yourself. And whatever sessions you want, do let me know in the comment section. Thank you, everybody.